Welcome to Algebra 1, Semester 2, Unit 11, Section 13.6. A lot of this unit I found is review for students because it deals with measures of central tendency, dispersion, some data collection that you've done in the past. Please still watch the videos and learn the terms because the vocab is very important. Measures of central tendency are the mean, median, and mode. Dispersion means how far apart data values are dispersed. Another word for this would be the range or the deviation. Okay, so now we're just going to do some quick data things so that you make sure and review this. To find the mean, I want you to also realize mean has a symbol, X with a bar over it. X bar is mean. Please start to recognize that as such. It's in your vocab. In order to get the mean, it's mean to do, we have to add up 1,181 plus 1,191 plus 1,200 plus 1,268 plus 1,000 plus 2,584 plus 1,000 plus 1,328, all divided by 8. If you add all those up, feel free to use a calculator. You would get 10,752 divided by 8, which equals 1,344. For the median, remember it is the middle number. How you find that is to put them in order first. So we do 1,000. The next order would be the next 1,000. Next would be 1,181. Next 1,191. Next 1,200. Next is 1,268. Next is 1,328 and 2,584. And then what you need to do is just tick them off to the center. So we have one there, one there. One there, one there. We're just narrowing it to the center. Notice how we end up with 2 in the center. Add those two together and divide by 2, and that'll show you what's halfway between them. That would be 2,391 divided by 2 equals 1,195.2. Now the mode is the most often occurring, mode most, and it is 1,000. So which of these best represents this data? The mean being 1,344. Well, if we look at it in this sense, where they're in order, 1,344 is clear up on this end. So the mean's not a real good representation of all this data. The mode is way down on this end. It's not a real good representation. And the median is 1195. It's right about here in the middle. Between them all, that's a pretty good representation, even though that middle isn't the middle as far as the number of feet. It's the middle in our data. It's a better representation where there's only one that's way out there as a big number. So the best representation would be our median. We go ahead and we list these down in the blank. So we have 1,344. We have 1195.2, and we have 1,000. Now it asks us to calculate the range. Well, our greatest value is 2,584, so range, we would take the largest number, 2584, and our smallest number was 1,000. So we subtract 1,000, and we get 1584. So our range is 1584. What if the greatest value in the data above is eliminated? Which measure of central tendency best represents the remaining data? Well, if we did that, we would end up with the largest one being taken away. So when we add up 1,000, 1,000, 1181, 1191, 1200, 1268, and 1328, we end up getting 8,168. This time, remember, we divide by 7, because there's only 7 items now. And we would end up getting 1166.9. 1,000, or I mean, 1,000. 1,166.9. Okay, that's for our mean, x bar. Our median now, if we go to the center of this data, well, we have 1,000 there, 1328, 1,000, 1268, 1181, 1,200. Our median is now 1191. And our mode still remains at 1,000. So now which one's the better one to use? Well, when you don't have an outlier being a measurement that is way far away from the others, when you don't have an outlier, your mean is actually a better indicator, because we got 1166.9, which is right about here. And it covers for how far down this goes here and how far up there. Okay? The 1191 is still okay, but it's a little bit too high for this set of data now. And the 1,000 is way too low. It's down here on this end. So just remember, when you have an outlier, do not use the mean. The mean is only useful when there's not an outlier. Okay, next page, page 4. Charlie has 3 math tests. He's got a 93, an 84, an 87. He's taking another test tomorrow. What score does he need to bring his average up to a 90%? Well, there's our 93, our 84, our 87, and now the test tomorrow, we don't know what it'll be. We'll just say it's T. T is tomorrow test score. Anytime you use a variable in an expression, you should define it like that. Now we're going to add all the test scores up, divide by 4, and he wants to end up with a 90% average, correct? Or to get this T by itself, we'd multiply by 4 on each side. And we would get 9, those reduced, 9,3 plus 8,4 plus 8,7 plus T equals 4 times 90 would be 360. Now if we combine these 3, then we can more easily get them on the other side without the T. And in doing that, we get 264 plus T equals 360. Now to get the T all by itself, we subtract 264 from 360. And that shows us that we need to have a 96 on today's math test in order to raise the average to 90. Okay. find the measures of dispersion. This is the range in absolute value deviation. On this one, go ahead and find the range. You did it on the last page. And it would be taking the highest number and subtracting the lowest number. So when you look at the data, there you've got your highest number. You've got your highest number is 15. And you are subtracting your lowest number, which is 10. And so your range comes out being 5. Now, mean absolute value deviation. You remember the last lesson, we showed you that the mean is, or we actually just did it, where we add up all the numbers and divide by the number of items there are. Absolute value, do you remember what that means? What does absolute value mean? Absolute value, remember, is the distance from 0. And deviation, we talked about yesterday, or dispersion we talked about, it is the spread numbers are. So if we're looking for the mean, absolute value deviation, what it means is that we are taking the first item and we're subtracting from it how far it is from the mean, or we're subtracting the mean to see how far that is. Now, we need to take absolute value in order to not get negatives or pluses involved in this, and we just add the next item. So we're really going to see how far is everything from the mean. So let's do that much. If we look at the mean of all these numbers up here, let's find the mean of those. First, let's put them in order. We have 10, 11, not that you'd have to find the mean, 12, 13, 14, and 15. So if we add all of these up together, we would get 10 plus 11 plus 12 plus 13 plus 14 plus 15 equals 75. We're just looking for the mean or the average. Now we divide by 6, we get 12.5. So there's our mean, 12.5. We want to know how far spread out is all of this from 12.5 or from the mean. Well, if we look at that, 10 would be 2.5 from 12.5. So that's what we're doing by plugging this in and saying 10 minus 12.5. As long as we keep the absolute value there, we don't end up with it being a negative, it'll be 2.5. Now we add to that, how far is 11 from 12.5? We would plug that in by showing 11 minus 12.5. And it's 1.5 away. The 12, how far is it? Well, it's only a half away. This keeps going in your formula, so just keep putting them in here. 12 minus 12.5. That's 0.5. Same thing with 13. It's only 1/2 from it. 0.5. Now look at what would happen if we didn't have absolute value. all these would be negative, and then the ones on the other side would be positive, and they'd cancel each other out. That wouldn't be right to have a deviation of 0. So that's why we have to use absolute values, is so that we don't cancel each other out. We're still finding how far it is. The other thing is we don't want a negative deviation, because that's a distance from the mean too. It's how far it's spread out. Plus 14 from 12.5. That would be 1.5. And 15 from 12.5 would be 2.5. Now, because we're finding the mean absolute deviation, we're going to divide by 6 again. So we add those up. 2.5 plus 1.5 plus 0.5. Now, when you come to class, I will show you on a calculator how you can do this a very simple way, but I'm just wanting you to make sure that you understand it, why we're doing this. So, we get them all added together. We got 9 divided by 6 should be about 1.5. So 3 will go in there 3 times, 3 will go in there twice, 1.5. So in other words, the average amount that they're spread out from the mean, being 12.5, is 1.5. It's out about 1.5. If you think about that, this one being 1/2 and this one being 2.5, they round each other off to being about 1.5. So that's what we mean by mean absolute deviation. That's the end of today's lesson. We'll see you tomorrow in class.